All right, Fred Dog, ready to do some homework?
Yeah, I'm ready. What did you call me?
Oh, sorry about that. Ready to do some homework, Fred?
Yeah, I guess so.
What do you mean you guess so? You don't like it? Yeah,
I like it, but I don't like being called Fred Dog.
All right, never again.
Okay. So, what do we got?
What number should replace the question mark in each of the following?
Okay, so we're converting centimeters to meters, right?
Yeah, converting centimeters to meters. Now, these aren't actually kind of conversion problems. It's just testing whether we know the prefixes, right? So, what do you think? 1 meter? How many centimeters?
Yeah, there you go. I remember the centimeters. Centimeters is just simply a 100 centimeters per meter.
Very good. So that first one's going to be 100. How about B?
That's kilo. That's 1,000.
Very good, 1,000. And we can look this up in the book, correct?
Yeah.
Yeah, there it is, page 35 in our book, right? All of our prefixes that we need to kind of remember, okay? Become familiar with gradually. All right, so 1,000 meters per kilometer. What about this one, meters to picometers?
Pico was smaller than nano, and nano was 9, so that's going to be 1 with 12 zeros.
Very good, 1 with 12 zeros. I don't know what we call that. That's not a billion, that's a trillion, right?
Yeah, I guess so.
All right, decimeter. Nobody talks about a decimeter, but deci is what?
Decimal?
Yeah, but I mean, what is decimal? What's the number that's associated with the prefix des?
Like decade?
Yeah, do you know the number?
Oh, it's 10.
That's right, so 1 decimeter, is that 10 meters?
No, the deci is smaller, right?
That's right, so it's 0.1 meters. Very good. Grams to kilograms?
Well, there's 1,000 grams per kilogram, so that's 1/1,000th, which is, what is that?
1/1,000th? I think that would be 0.001. Is that right?
Yeah.
So that's how many kilograms are equivalent to 1 gram.
Okay.
And F, what do we got there?
CGC, is that cena?
Yeah, cena. So what?
Okay, so 0.01.
Very good. 0.01 grams for every centigram. All right. 228. Perform the following conversions, right? Now, I'm not a fan of going from degrees Celsius to Fahrenheit, all right? So I'm not going to hold us to any of those. The best way to do those is just to go to Google and kind of figure that out. But our Celsius to Kelvin ones, I do want us to always know how to do that. So E, what do we need to do to go from Celsius to Kelvin there?
What was the number?
273. 273, 273.15 if you want to be precise. What do you do with 273.15?
Well, you either subtract it or add it.
Very good. And if we're going from Celsius to Kelvin, do we want to subtract that 273 or add that 273?
I can't remember.
Well, what would happen if we would subtract the 273? What would that mean we'd have with Kelvin?
Negative 210.
That's right. It would be negative, right?
Oh, yeah.
And what? What's wrong with that?
You can't have Kelvin negative.
That's right. So there we see that we have to what?
Add the 273.
Very good. So the 62 plus the 273 is going to be our answer there. All right. Whoops. What did I do? 62 plus 273, not times. And then the other one is a negative 31 plus the 273. Ugh. There we go. No. There we go. Good deal. Okay, 242. All right, excellent. So we got 233 on the first one and 335 on the first one and 242 Kelvin on the second one. Good job, Fred.
Thank you very much.
Okay, healthy dog has a temperature of about 37.2 degrees Celsius to 39.2 degrees Celsius. Is a dog with temperature of 103.5 Fahrenheit within that normal range? It's a good question. Go ask Google. They'll let you know what the relationship between Fahrenheit and Celsius is there.
That's it?
Yeah, we're not going to spend time with Celsius to Fahrenheit. All right? I don't find myself ever having to do it in the chemical world. All right, next one. Estimate the temperatures of the core of the sun range from 10 megakelvin to 25 megakelvin. What is this range in degrees Celsius? So we're just going to go degrees Celsius. So what do we got to do?
10 megakelvin?
Yeah.
10 megakelvin? Gee whiz, what is that? How many zeros is that?
Do you remember mega?
Let's see. Kilobytes is 1,000, and then megabytes. So that's a million?
That's right. Million. So 10 million Kelvin to 25 million Kelvin. What's that range in degrees Celsius? How do we go from Kelvin to degrees Celsius?
Well, we added the 273 to go from Celsius to Kelvin. So here we got to go subtract the 273.
Yep, but if we subtract 273 from 10 million, how is that going to change things?
Not much.
That's right. So essentially, for our very high temperatures like that, there's not a significant difference.
Okay, got it.
Helium has the lowest boiling point of any liquid. It boils at 4 Kelvin, and that makes helium a critical component so far currently to many medical instrumentation like MRI and other instrumentation that is going to look through you and image your system. So, having helium around is very critical. It boils at 4 Kelvin. What is that boiling point in degrees Celsius?
Didn't we decide we have to subtract the 273?
That's right. Subtract the 273. Now, 4 Kelvin, is that an interesting number to you?
Not really.
Okay. Well, remember what the lowest Kelvin can be?
Oh, yeah, it can only be 0, huh? So that's like really cold.
That's right. It's really cold. So, we're close to our lowest temperature that we can get. So we're going to take 4, subtract the 273. Working here? Oops, okay. So, negative 269. Now, is it okay to have a negative number?
Oh, I thought it wasn't. Let's see. Oh, yeah, you can have a negative number because this is in degrees Celsius.
That's right. Negative 269 because we're in degrees Celsius. Okay, good. All right, Fred, how are you at significant figures?
I'm not bad.
Very good. So, what do you think there? Are any of these easy to do?
Yeah, A is easy because it's all real numbers, so that's 4 significant figures.
How about B?
Well, B is kind of tricky because the 0 at the end, but if the 0's at the end after the decimal, it's always significant, right?
If it's at the end after the decimal, then it's always significant. Very good. So that's how many?
5, and the C is 4.
Good. How about D?
Now, those zeros aren't significant, right?
That's right. All those zeros are not significant because there's no values, there's no measurement that can actually fill them up, no amount, right? No mass in this case because we're talking about kilograms. So, only how many?
Just 2.
That's right. And which one is the estimate?
The estimate? I don't know. What do you mean?
Well, remember, the last significant figure is always the estimate.
Oh, yeah, so the 4.
Very good. The 4 is the estimate here. All right, how about the E? How many significant digits there?
That last 0 is still significant, right?
Yes, it is. So, what does that mean?
Well, I guess that means there's 4 significant figures.
Very good. And F?
So, are those zeros significant?
Well, we've decided that zeros after significant digits are not significant in front of the decimal point unless there's a decimal point. So we use the decimal point to indicate that they're significant, but because there's no decimal point here, it's telling us that those numbers aren't significant. So the 4 is the last estimate, is the estimate, right? So we just have how many significant figures?
Just 2, I guess.
Very good. 2 significant figures. All right, we get to do some math. So I'm going to bring in the calculator to minimize the brain cell usage. It's great to use a calculator. There's nothing wrong with it, right? You have lots of different things to think about, and you should be spending time thinking about those things. There's a lot of people who are better than math than me, but to me, I want to save my brain cells for other things and make sure that I don't make small accounting errors that cause problems, right? All right, so perform this arithmetic. We have to make sure we get our units and the correct number of significant figures. All right, so what do we got? 0.0023 times 315. Okay, answer is 0.7245. How many significant figures?
Well, you got 2 in the first number and 3, so the answer is just 2 significant figures, or 0.72.
Very good. 0.72. And what are the units?
0.72 meters.
0.72 meters. Is that right?
Yeah.
Something's wrong there, Fred.
Oh, meters times meters. That means the units are meters squared.
Very good. Multiplying meters together will give you meters squared. Okay, excellent. That's A. How about B?
84.25.
Minus what?
Minus 0.01075.
Okay, both are kilograms, right? And the answer there, 84.23925. How many significant digits do we have?
Well, we had 4 in the first significant digit and 4 in the second, so it must be 4 significant digits?
That's not the right thought process for addition and subtraction, Fred.
Oh, well, what are we supposed to do?
Well, for addition and subtraction, remember what we're supposed to be doing is we're supposed to be writing it down and lining it up. So there's problem A, here's problem B. We have to write it down and line it up, 84.25 and 0.01075. And then we identify where our significant digits should run out, which is right there. So the answer is going to be 84.24 because I'm going to use that 9 to round up that 3. Okay, so, and what are our units?
Kilograms minus kilograms. That's just kilograms, right?
That's right. Very good. Kilograms. Okay, C. What do we got to do for C?
Do we have to do what's in the parentheses first?
Yeah, we have to do what's in the parentheses first, so we can start on either side. We'll start on the left. So 184.45 minus the 94.45. Okay, so 90. How many significant figures is that going to have?
90, that's just 1? Is that right?
Okay, so another example where we have to line it up. 184.45, 94.45. Our answer is 90.00 whatever. And this is where our significant digits drop off, right? So the answer is 90.00, and we have 4 significant figures there, okay? Now that's just the first half of the problem, but we had to round or identify our significant figures because we're going from addition and subtraction in this case. Next step will be, after we do the other subtraction, we'll do division. So we have to gather our significant figures on both sides. So divided by the answer on the other side, 31.4, 9.9. All right, so 31.4 minus the 9.9, 21.5. And this is where our significant figures drop off, so we get to keep all 3. Now we have our 90 divided by the 21.5, 4.186. But how many significant figures do we get to keep?
How do we decide that?
Well, remember, this is now a division problem, so we just look at these.
Oh, then 3.
That's right, because this has 3 and that has 4 significant digits. So 4.19. And what are our units? What were the units on the 90?
90, that was grams. And that was milliliters.
Very good. So on our 4.198, it's grams per milliliter. Okay, very good. D, same type of thing, right? I'm going to be adding up all these numbers, 23.4, 102.4, 0.003. I can kind of do it in my head because I see that it's going to round to the tenths place. Can you see that?
Yeah, because 23.4 ends at the tenths place, and 102.4 ends at the tenths place.
Good, good. So 102.4, and then adding also 0.0003. All right, to the tenths place, 125.8. 125.8. Notice how if we hadn't even added that 0.003, you'd still get 125.8. And what we're seeing here is an example of, even though we had something that was really good at making that measurement, really precise and being able to give us that 0.003, we couldn't include it in the rest because it was these other two measurements were not accurate enough, right? Okay, very good. So 125.8 units are grams, and we're going to have to identify significant figures at this point because now we have to divide by our 6.478, and the units are milliliters. So 125.8 divided by 6.478, 19.4195. How many significant digits are we going to keep there?
You had 4 and 4, so 4.
That's right, 4. So 19.4, going to round to that fourth one, 2. What are the units?
Grams per milliliter.
Very good. Excellent job. All right, last one here, E. 313.44 minus the 209.1. Okay. Enter 104.34. Where are my significant digits going to end?
At the tenths place.
Very good. 104.3. Whoops. And then multiplying by, and this is in centimeters now. Now multiplying by 8.2234. So 104.3. I have to collect significant figures because I went from subtraction to multiplication, right? Centimeters here too. So 104.3 times the 8.2234. Whoops. Oh, there we go. All right, 8.2234, got it. So 857.7, and I get to keep how many significant figures?
1, 2, 3, 4. 1, 2, 3, 4, 5. Just 4.
Yeah, just 4 significant figures. So 857 point what?
0.7.
Yeah, that's right. And what are my units?
Centimeters times centimeters. So centimeters squared.
Very good. Centimeters squared. Excellent work. Okay, Fred, what do we got now?
Looks like we got some conversions.
That's right, conversions. So to do conversions, you know the tool, right?
Yeah, I think so.
What's the tool?
Well, we write an equal sign.
Very good. Write an equal sign.
Draw a line.
Very good.
Then write our units we're after.
So we want kilometers per hour.
And then start with decimeters. Is that what that is?
Yeah, decimeters per second.
32.
So I put 32 decimeters for every 1 second. Very good. Now seconds need to get to hours, and decimeters need to be converted to kilometers. Okay? I could just take one at a time. So let's just do decimeters to kilometers first. Is that okay?
Okay. So I know that decimeters, there's 10 per meter. So let's see. That is, well, decimeters goes on the bottom.
That's right. Decimeters goes on the bottom. Whoops. And then meters goes on top. And for every 1 meter, I have 10 decimeters. Good. Now I'm in meters, and now I got to get to kilometers. So I can go meters on the bottom and kilometers on the top. And there's 1,000 meters in a kilometer. Very good. Now we've gotten from decimeters to meters to kilometers, which is what we want on top. Now I just need seconds to hours. So seconds needs to go on top. And what am I going to convert it to?
I know minutes.
Very good. That'll do. Minutes. There's 60 seconds per minute. Is that right?
Yeah. And then you got to go to hours.
Okay, so minutes goes on top. 60 minutes for every 1 hour. Okay, very good. So the 32 divided by 10 divided by 1,000 times 60 times 60 should be our answer in kilometers per hour. Excellent job. So let's do B. Equal sign. What are we after?
We want it in micrograms per liter.
Micrograms per liter. And what are we in?
Milligrams per milliliter.
All right, milligrams, milliliters. 8.2. Okay, what do I got to do to get rid of the milligrams?
I'm not sure how many milligrams there are per microgram. It's probably like, 1,000th or something, but we can just go to grams, right?
That's right. You can always just go to grams. Milligrams to grams. There's 1,000 milligrams per gram. And now I got to get 2 grams to micrograms. Do you know that?
Yeah, micro is 10 to the minus 6.
That's right. 10 to the minus 6. Or that's a million, right? For every 1 gram. Or not 10 to the minus 6. 10 to the 6th micrograms for every gram. It would be 10 to the minus 6 grams for every microgram. Okay, so now I'm in micrograms. That's 10 to the 6, or a million there, remember. Now I got to get my milliliters here. 8.2 grams for every milliliter, 2 liters. So milliliters can go on top and liters can go on bottom. That's easy, right? There's 1,000 milliliters for every liter, right?
Yeah, okay.
Very good. So we see the milligrams go to grams, cancel out, and we get to micrograms. The milliliters go to milliliters, and we get to liters. So we're in micrograms per liter, which is what we want. 8.2 times a million, 1 with 6 zeros, times 1,000 divided by 1,000. These kind of cancel out, right? Okay. All right. C seems to be pretty straightforward, right? What goes to the right of the equal sign?
Kilograms.
Very good. And what are we starting with to the top left?
Milligrams.
Milligrams. So we just need to go from milligrams to, do you know how many kilograms there are per, or how many milligrams per kilogram?
No.
Let's just go to what? What do you know?
Grams.
So grams, and then we can go from grams to kilograms. That's easy, right? Don't try to make it more difficult than it needs to be. So what do we got? 75.3? 75.3 milligrams divided by 1,000 twice, or divided by a million. Okay, very good. And we can see the milligrams cancel out, the grams cancel out, and we're left in kilograms, right?
Yep, look good. Okay, what about D?
Milliliters to liters. Now this one is one that we can do, but also gradually you're going to be able to say, oh, I know that. But until then, I'll just use my method, right? Liters, milliliters, 137.5 milliliters, right? Milliliters has to go down here. Do we know liters?
Yeah, I know liters.
Right, so we know how many milliliters per liter, 1,000 milliliters per liter. So divided by 1,000, right? 0.1375. Good. All right. How about that many liters to milliliters?
Oh, you're just going to be timesing by 1,000.
1, 2, 3. So 25. Is that the answer? Yep. Should I write it down?
No, that's okay. I got it.
Good. How about the next one? Picometers squared to decimeters squared. Do you know that?
Well, I used to. I used to think about it every day, but not anymore since I quit my job.
Oh, really? You used to deal with that conversion?
Yeah.
Where did you work?
I don't want to talk about it. It was a horrible job. That's why I came back to college.
All right. So what goes to the right of the equal sign?
Decimeters.
Like that?
Decimeters squared.
Okay, very good. And then top left, picometers squared. Do I have to give myself a lot of space?
Not too much. I don't think it's going to be too hard.
It's scary though, isn't it? Because, you don't think about what it means and stuff like that, right?
Oh, I guess.
But it's really not that difficult, right? Picometers here, picometers squared. If we want to go to meters squared, Do you remember how many meters or picometers are in a meter?
I'll look it up in the book real quick.
Yeah, you can go back to that chart.
Well, actually, I do remember. Nanometers was 9, and pico is 12. So that's 10 to the 12th picometers for every meter.
Very good. 10 to the 12th. Now, that's picometers per meters. That's not picometers squared per meter squared. So that needs to be squared for every 1, and that's going to be squared too, but it's still just 1. Very good. And now we go from meters squared to decimeters squared. 10 decimeters for every meter, but we're doing decimeters squared. Okay, so we got it. Now, this is a little tricky to put into your calculator, so we'll do it together here. I mean, it's not terribly tricky, but there are different kinds of calculators, and I kind of want you to do large numbers like this a certain way, okay? Well, not that big of a deal, but 342 divided by 10 to the 12th. To the 12th. There we go. Hopefully you got a way to do that on your calculator. If not, time to get a good calculator. The sooner you get a good calculator and become familiar with how to use it, the sooner that becomes not the issue, right? That's not the issue. You want the calculator to be out of the equation. It should not be the problem or the thing that you're worrying about. I'll push enter there, and then I multiply by 10 squared. Whoops. Times 10 squared. Okay, 3.835 times 10 to the minus 9. We got 3 significant figures from 342, so 3.84 times 10 to the minus 9. Okay, good work, Fred. All right, so we're going to do some more conversions here, but we might need some stuff that we don't know. I think we might be able to do inches to centimeters. Do you remember that one?
Yeah, I do. 2.54 centimeters per inch.
Good. And if you didn't, you look that thing up on YouTube. Not a problem. Sorry, Google. But I think it's healthy to write down our equal sign. We're looking for centimeters. We have inches, and then we need to go from inches to centimeters. So that helps us to see that we have the 2.54 on top. So that's 36 times the 2.54 to get us our centimeters. Okay? All right. How about B? What are we going to do for that one?
Equal sign, kilograms.
Very good.
5 pounds.
Good. 5 pounds. Do you know how many pounds per kilogram?
No. But it says we can refer to the tables.
Let's see if we got it there. There it is. 1 pound is 435.6 grams, or that would be 0.4536 kilograms. So 1 pound, 0.4536 kilograms. All right, so the 51 times the 0.4536 kilograms. Good. C, quarts to liters. What goes here?
Milliliters.
Oh yeah, milliliters, not liters, sorry. Milliliters, 3.0 quarts. Where can we go with quarts?
Is there anything on that chart?
Let's see, anything on there? Quarts to milliliters, 946.4, 946.4. And the big deal is making sure the quarts go down here, milliliters go down here, because our units are going to be like that. So 1 quart, 946 milliliters. Okay, very good. All right, let's get to D. 1 cup, which is 8 ounces, to milliliters. Equal sign, milliliters, right? 1 cup, or 8 ounces. Let's see what we learned there.
Those ounces, 29.6 milliliters per ounce.
Okay, 29.6 milliliters per ounce. So this 1 cup is 8 ounces. And then 1 ounce is 29.6 milliliters. Okay, so 1 times the 8, this is 8 OZ, 8.0, or just 8 ounces. 1 times 8 times 29.6 will give us our milliliters. Good. What's next?
Miles per hour to kilometers per hour. And that's a big deal because I often visit UK.
What's UK? Is that urban Kentucky?
Yeah, and there they use kilometers per hour as opposed to miles per hour.
Okay. All right. So kilometers per hour, and we're starting in miles per hour. Very good. And miles will be converted to kilometers, hopefully. Or do you know miles to kilometers?
No, I don't really.
It's probably on that table. Let's see if we can get that table here. There it is, 1.609 kilometers. 1.609 kilometers per every mile. And now, oh, we're already in hours. Well, that was easy, right? So what are we starting with? 50? 55. 55 miles per hour to kilometers per hour. Okay, very good. Last one, miles to kilometers. 50 miles. Here we're just going again, miles to kilometers. Here we want only kilometers, so we can use that same 1.609 kilometers for every hour. Just making sure that's right over there on that table. Yeah, that's right. 1.609 kilometers for every hour. Okay, very good. Good job.
Thank you very much. What's next?
Okay, we got some more conversions. Feet squared to centimeters squared. What do you think, easy or hard?
Well, this is going to be easy because we've done practice and we've done this one before.
Pretty much, huh? What goes to the right of the equal sign?
Centimeters squared.
Very good. And we start with what?
Feet squared.
How many?
8.4.
Okay, 8.4 feet squared. The only kind of scary thing is like feet squared. You know, what does that mean? We know going feet to inches and then going inches to centimeters. That's easy, but what about squared?
It's not a big deal. You just square the number also. So 12 inches gets squared and the 1 down there gets squared. Not that that means anything because it's just 1 squared. And then 1 inch squared and then 2.54 squared as well.
Very good. So you got 8.4 times the 12, but twice, right? Or 12 squared, times the 2.5, but twice 2.54 squared. This is just 1 here and 1 there. So excellent. How about the miles squared to kilometers squared?
What was the miles per in every kilometer?
I'm not sure. I can't remember. It was on the that table, right? 2.3.
Yeah.
So here it is. Length, 1 mile is 1.609 kilometers. All right. So if I go miles squared to kilometers squared, like that, right? What was it? 1 mile is 1.609. Right? And if we start with 223, do I just multiply by 1.609?
Well, you need to square it.
That's right. Multiply 1.609 squared. And then, you could think of that 1 as being squared as well. Okay? Very good. Last one here. Feet squared to centimeters squared. Same stuff here. Instead of the 8.4, 231. Right? 231 feet squared. Oh, no, feet cubed to centimeter cubed. So this 12 is now going to be cubed, and this 2 is now going to be cubed. And this is going to be cubed, and this is going to be cubed. Those 2 on the bottom are still just 1. So 231 times 12 3 times 2.54 3 times. Okay, good work.
You did that last one all by yourself.
Sorry about that. Kind of hogged it. Ooh, look at this one. A human stomach can expand to hold 4.2 quarts of food. A pistachio nut has 0.9 milliliters. Use this information to estimate the maximum number of pistachios. So, equal sign number of pistachios. All right, how many pistachios are we going to be able to fit into our gut, which is 4.2 quarts? All right, so I got 4.2 quarts, right? I'm going to show you something, another valuable tool. I'll look up in the table to see what we can convert quarts to in a bit here. Maybe you remember. Do you remember, Fred, off the top of your head?
Well, yeah, I know. But I'm going to let you figure it out.
Oh, okay. Good deal. So we'll get to quarts to liters and then liters to milliliters. But a way we can work backwards is we can know that we want to end up with the number of pistachios up on top here, right? And I can use that conversion factor and say 1 pistachio is 0.9 milliliters, right? So I'm kind of working backwards. And then I can go from milliliters to liters, right? 1,000 milliliters per every 1 liter. And then I can just look up how many liters there are in a quart. So I'm going to get my phone here and just ask it really quick, because how many liters are there in a quart? Try again. How many liters are there in a quart? All right, so it says
1 quart is equal to 0.946 liters. To convert from quarts to liters, divide unit of volume by approximately 1.06.
0.946 liters. All right, 1 quart is 0.946 liters. Okay, there we go. So quarts go to liters, liters go to milliliters, and then there's 0.9 milliliters for every pistachio. So I can get the number of pistachios that is equivalent to 4.2 quarts. Okay, good job. A hurricane question.
Why is that good?
Well, it's not good or bad or nothing, but hurricanes always come close to Hawaii, don't they, Fred?
I guess. Haven't been here very long.
Don't worry, they don't hit very frequently. Only 3 or 2 in the last recorded history. So, in all recorded history, I should say. 200 miles per hour, what's that wind speed in meters per second? Meters per second. What goes to the right of our equal sign, Fred?
Meters per second.
Very good. Meters per second. What do I start with, top left?
200 miles per hour.
Like that?
Yeah, that's right.
So, if I want to go from miles to kilometers, do you remember that value?
Oh, man, we just did it.
Yep, I forgot it already. But I can ask this question. How many miles are there per kilometer?
To convert from kilometers to miles, divide unit of length by approximately 1.61.
So 1 kilometer is 0.621 miles, it says. Okay? So we were going the other way before, but it doesn't matter. We were talking about 1 mile, how many kilometers? 1.6 something, right? So here we got kilometers, and now we just need to go to meters. Very good. That's easy, right? 1,000 meters for every kilometer. Now I need hours to seconds. 3,600, right? Or, 60 times 60. But does it go up here, go down there? Don't have to worry about it. Just say hours, minutes, 60 minutes, 1 hour, and then minutes to seconds. So 1 minute, 60 seconds. So our 200 divided by 0.621 times 1,000 divided by 60 divided by 60. Our hours are converted to minutes, and our minutes are converted to seconds. That's what we wanted. Our miles were converted to kilometers, which were converted to meters, which we wanted. Okay, excellent job. All right, a bullet question.
Oh, I hate guns.
Yeah, they're not fun, are they?
Well, they just taste horrible.
Taste? Why are you tasting guns?
Oh, I don't want to talk about it.
Okay. Anyways, a bullet leaving the muzzle of a pistol was traveling at speed of 2,230 feet per second. What's the speed in miles per hour? All right. Miles per hour is what we're looking for. And we're starting in, give myself a little more space. We've been running out lately. Feet per second. Seconds can go to minutes. And then minutes can go to hours, right? We've had that experience from doing our homework, right? So how many seconds per minute?
60 seconds per minute.
And here?
60 minutes per hour.
60 minutes per hour. Very good. How about, well, what was it? 2230 feet per second. How about feet per mile? Do you know that?
Is it 5,280?
Let's find out. How many feet per mile?
1 mile is equivalent to 5,280 feet.
Very good. 5,280 feet for every mile. So feet gets canceled out there. We're left in miles. Seconds, minutes, we're left in hours. Miles per hour. Okay. 2230 times 60 divided by 5,280 should do the job.
Great.
Yeah, great. Okay, the brightest star in the sky is Sirius, the dog star. That's why they call them the dog days of summer. Did you know that?
No, what do you mean?
Well, when the dog star's out, that you can see the dog star, that's usually during summertime. And Sirius is called the dog star. Okay, so when the distance from Earth is 8.7 light years, and a light year is the distance that light travels in 1 year. Okay, so we got 3 times 10 to the 8th meters per second. That's the speed that light travels. Calculate the distance from Earth to Sirius in miles, and then they tell us 1 mile is 5,280 feet. Whew, lots of fun stuff here. So, I want my equal sign in what? Or I want my units. What do I want at the end of my equal sign?
Calculate the distance from Earth in miles.
That's right. So MI will stand for miles. Is that okay? Don't need to be lazy, I guess. So, what are we going to start with top left?
Well, if we started with the 8.7 light years?
8.7 light years. So that's a light year is the distance travels in 1 year. So it's 8.7. It's how fast light travels in 1 year. We have 3 times 10 to the 8th meters for every second. So we need to find out how many meters that is in not 1 second, but how many meters that is in 1 year, and then convert that meters to miles and multiply by 8.7, right?
Okay, I guess.
Well, let's try to write it down and try to get some understanding here. Miles and meters are both distance, so I'm okay if I write 3 times 10 to the 8th meters in 1 second. Right? Does that make sense? We have meters on top, and that's a length, and we want to end with miles. So now I just need to get rid of the seconds on the bottom by knowing how many seconds, and it takes 8.7 years worth of seconds. And then I also have to get the meters to miles. So let's get the meters to miles first. What was the kilometers per... How many kilometers per mile?
To convert from miles to kilometers, multiply unit of length by approximately 1.61.
So we'll go from miles to kilometers, and then we'll go from kilometers to miles. Sorry, meters to kilometers, and then miles to kilometers to miles. So there's 1,000 meters per kilometer and 1.609 kilometers for every mile. So I went from meters to kilometers and kilometers to miles. Does that make sense?
Yeah, I guess that's what you had in your table there.
Right? Yeah, that's why we use kilometers to miles, because that's a number we've been using a lot. Okay? Now we have to get seconds into years. Okay. Well, we might run out of space here. Let's keep it tight. Seconds will go to minutes. And then minutes will go to hours. And then hours will go to days. And then days will go to years. So, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365, close enough, days for every year. Now, if I were to finish, I'd be in, let's look at our seconds. They cancel out there. Minutes cancel out there. Hours cancel out there. Days cancel out there. It's going to travel. Meters goes to kilometers. Kilometers go to miles. So now I'm how far it travels every year. So it travels that many miles. Its units are going to be in miles per year. But I don't want it to be in miles per year. I just want miles. So I need to get rid of years. So the last thing I need to do is have years up here, which is our 8.7 years. Okay, very good. 3 times 10 to the 8th. Let's see if we can do this one on the calculator. 3 times 10 to the 8th. Divided by 1,000. Whoops. 3 times 10 to the 8th. There it is. Oops, clear. 3. Oh, no, it's not 3 times 10 to it's not 3 to the 8th. Clear. It's 3 times 10 to the 8th. Did you see how I did that? Oh, you can't see. There we go. Try again. It's 3 times 10 to the 8th. And that's the way we want to do it in our calculators because that will minimize what do you call them? The errors associated with the order of operation in your calculator. So 3 times 10 to the 8th divided by 1,000 divided by 1.609 times 60 times 60 times 24. You following, Fred?
Yeah, I'm following.
Times 365 times 8.7. 76,212. That is not right. What did we do wrong, Fred? Oh, we didn't multiply this times those last ones there. So let's get this number in here. That number, because we were supposed to take this and then times by 24 times 365 times 8.7. But we didn't. So I'm going to bring this down here and then just multiply it by that value there. There it should be 5.1 times 10 to the 13th. Did it say assume a certain number of significant figures, or that was a different problem? 5.12 times 10 to the 13th miles. Okay, very good. Next. So the deepest point in Earth's ocean, 1,000 miles. Oops, I didn't get the whole question here. Just a second. Its depth is 6,333.5 fathoms.
It's unfathomable. Without fathom.
1 fathom is defined as 6 feet. Calculate the depth in the Mariana Trench in meters. So we want to go to what? What's our equal sign there, Fred?
Meters.
Very good. And what do we start with?
Unfathoms.
That's right, fathoms. FTH, is that good for fathoms? I see that fathoms can go to feet. And feet per meter, I could, ask Google, but I'm just going to have some fun. Go from feet to inches, and inches to centimeters, and then centimeters to meters. Because I know centimeters to inches. That's what?
2.54.
That's right, 2.54 centimeters per inch, 12 inches per foot, 6 feet per fathom, apparently, and then 100 centimeters for every meter. Fathoms, 6,033.5. Why do they work in fathoms? Probably a really good reason. So 6,033.5 times 6 times 12 times 2.54 divided by 100. 11,034 what? Meters. 11,034 meters is 6,000 fathoms.
Amazing.
That's right. Okay, now we're using density as conversion factors, right? Sample of kerosene has 36.4 grams. Its volume was measured to be 45.6 milliliters. What is the density of kerosene in grams per milliliter? This kind of question just kills me, right? Because, it says right there what they want you to do. They want grams per milliliters. Now, hopefully, this doesn't scare you away. Grams, milliliters, -1. Do you know what that means?
Yeah, I know what that means. It means the milliliters is on the bottom, like grams over milliliters.
Very good. Okay, so the -1 just means it comes down here. In other words, 5 to the -1 is equal to 1/5, right? For example. Okay, very good. So they just want the density in the units of grams per milliliter. And so if they've told you grams, 36.4, divided by your milliliters, 45.6, your answer is going to have 3 significant digits. Okay, very good. Acetone, the solvent in some nail polish removers, has a density of 0.791 grams per milliliter. What's the volume in milliliters of 25 grams of acetone?
Now, this kind of confuses me a little bit.
Well, it doesn't have to. We just do the same thing. We just write an equal sign and try to write the units that we're after, write down what we have, and see if we can get there somehow. So, what goes to the right of the equal sign?
They want to know volume, milliliters.
That's right, milliliters. And what do they start with?
Do we start with density or do we start with grams?
Well, we can do either one. Let's start with the density. What would I put down?
0.791 grams per milliliter.
0.791 grams for every 1 milliliter, like that.
Yeah. Now what do you do?
Well, now you just look and hold still for a second and see that the milliliters are going to be on the wrong side of your fraction, right? Can you see that?
Oh, yeah.
So if I wanted to start with the density, I need to make sure that I start with, and that's not a problem to write something down and then just start over. That didn't hurt a single thing. 0.791 grams like that, right? Now I have milliliters up top, and I just need to get rid of the grams, so I need my 25.0 grams. Okay, so I can see the units do what I want them to do, and I get my answer. Got it? So 25 divided by 0.791. Another way that some people will do it is start with the 25 grams, and then your density, again, has to go in here, but it would tell you that, again, your 0.791 has to be down there, and your milliliters has to be up there, right?
Okay, got it.
So yeah, 25 divided by 0.791, 3 significant figures, right? Excellent. All right, another density question. What's the mass in grams, 185 milliliters of the chloroform?
Well, I learned from last one. You just write the units, equal sign, and the units you're after.
Okay, so I'm after what this time?
Grams, mass in grams.
All right, and then I can start with what?
Well, it doesn't matter, but make sure you keep your grams at top. So maybe the 1.492 grams per milliliter.
All right. I like to start with the milliliters, but 1.492 grams per milliliter. That's all right to start like that as long as you have your grams up top. And then you can use your 185 milliliters there. Is that right?
Yeah.
Okay, so 1.492 times the 185 this time. Okay, good job. Okay, so we have an object. We put it into some water here, right? Putting an object into some water, and the water goes up 3.3 milliliters. That means what?
Well, it means that the volume of the object was 3.3 milliliters.
That's right, because the water is displaced by the object. Here's the object. And I put it into the water, and that much change in volume, that's our volume of the object, right? So 15 here, 18.3 here, that's 3.3 milliliters. Okay? And we see that the mass of the object is 27.35. All right. No. What was it? It's mass. So the graduated cylinder was filled with water, marked and weighed on a balance. So 27.35 was the mass of the system before the rock was put in, or this item. So the new mass is 62 grams. So we could do the 62 minus the 27.35. Okay, so that tells us 34.63, and that mass must be from what?
The stuff you put in.
Yeah, not just the water, but the grams of the solid, right? Because they're saying that it was filled with water, and its mass, meaning the graduated cylinder and the water. And then the object made of silver was placed in the cylinder and submerged, and the level rose to 18.3. Okay, very good. All right, so we got 34.65 grams, dividing it by the 3.3 milliliters, and it should be 10.5. And I'll just, for fun, ask my phone what the density of silver is. What is the density of silver?
Silver's density is 10.49.
All right, and the units I see here are grams per milliliter. Now see, it doesn't know anything about, the phone doesn't know anything about my piece of silver here, right? Because density is an intensive property. That means that it is going to be the same density for silver no matter where it is, because you're taking the ratio of its mass to its volumes, and all silver has the same density. Okay, if you think about porous silver, it still has the same density, the material itself. The volume that it takes up will mostly be air pockets and stuff, and those air pockets will be exposed to the water if it's put into a flask or a container like this, and so the displacement will still just be the silver. Now, if you actually have a balloon of silver and you're keeping air inside, then you're going to get a different kind of measurement, right? Okay, the space shuttle uses liquid hydrogen in its fuel. As its fuel, or I should say the space shuttles used to use liquid hydrogen as fuel. I don't know, maybe the new SpaceX ones do as well. But the external fuel tank carries 227,000 pounds, 227,641 pounds, 227,641 pounds of hydrogen with that volume, and we want to calculate the density of the liquid hydrogen in units of pounds per gallon, and in units of grams per milliliter. Okay? Right?
Yep.
So 227.641 pounds. 385,265 gallons. That's pounds and that's gallons. So that one's pretty straightforward, right? Just divide those numbers.
Yeah.
Now, if we want it in grams per milliliters, I need to get this pounds to, let's find out what that number is really quick, because then we don't have to deal with so many numbers. Okay, so let's go 227.641 divided by 385.263. So 0.59087. And that's pounds for every 1 gallon. Very good. And now we'll be able to go from pounds to, let's see, do I know how many pounds there are in a gram? What do we know? Yeah, I'll just ask my machine here. How many pounds are there per kilogram?
To convert from kilograms to pounds, multiply unit of mass by approximately 2.2.
2.205 pounds per kilogram. So now we're in kilograms, and we want to go from kilograms to grams. So 1,000 grams. So that value divided by 2.205 times 1,000 will give me my units in grams per milliliters. And the specific gravity is when it's calculated in terms of grams per milliliter. So that will be our specific gravity. Well, way to go, Fred. You finished all of our work for me.
I didn't do much on that last one.
Sorry. Yes, I got carried away, and I was just telling you.
Okay, well, watch it next time, because I'd really like to help a little bit more.
Okay, got it. Thank you very much. See ya.
Bye.